Good evening, dear all. Let us continue with the topic dimension analysis, class 11. I am Dhanu Saraiya. So, I am continuing the topic now. That is the correctness of the equation using the homogeneity principle of the dimension analysis. Now, today I have selected some numericals in which we have to find out the dimensional formulas of the given variables in the question. So let us start with a question in which in a gas equation P plus A upon V square, V minus B is equal to RT. Now P is the pressure here, V is the volume here, and T is the temperature here, and R is the Rayford constant that is already known to us and given to us. What are the dimensions of A and B are asked. As seen here, P is the pressure, T is the temperature, V is the volume. Now, using these dimensional formulas, which we already know, we have to find out the value of A and B. Fine. So, let us start now. What principle we have to use? For checking the correctness, we are using the principle of homogeneity. What is the homogeneity principle? When we add, subtract, or equate, the physical quantities must be same. That is, if I add mass, I have to add it to another mass, length to another length, time to another time. What operations I can do? Either I can add them or subtract them or equate them. Same physical quantities can be used in that. Using that, let us now find out the value of A and B. Now let us first find out the value of B. V minus B. V is volume. B we don't know, but using homogeneity principle, if V is volume, then B also should be volume, right? So what it should have? It should have the dimensions of volume. Therefore, the dimension of B also should be having the dimension of volume. What is the dimension of volume? M raised to 0, L raised to 3 and T raised to 0. So, we got the dimension of B. Now, let us try the dimension of A. Now, if P is the pressure, then A upon V square also should be pressure, because we can add the same physical quantities only according to the principle of homogeneity. So, A upon V square should have the dimension of pressure only. Why I am using the word only? It cannot have any other dimension. It should have the dimension of pressure because it is added to pressure. Correct? Okay. So, therefore, what is the dimension of A then? A is the dimension of the pressure. What is the dimension of pressure? M raised to 1, L raised to minus 1, T raised to minus 2. This is with our memory. Okay. So, I must multiply it the dimension of V square. So, what is V? Dimension of V, just now we wrote, I have written, but I have to square it now. I have just taken this V square up and I have written its dimension here. So, what is my answer? Let me multiply this pressure dimensions I have written as it is. And this I am squaring it. So, this becomes L raised to 6 and the other two are raised to 0. So, what is my answer for A now? Because bases are same, I only have to add the powers. 1 plus 0, 1. L raised to minus 1 plus 6, minus 1 plus 6. T raised to minus 2 plus 0. So, what is my final answer for A? M raised to 1, L raised to minus 1 plus 6, so 5, and T raised to minus 2 plus 0, so negative 2. So, this is the dimension of A, and this is the dimension of B. As asked to us, in both the cases we have used the dimension of P, V as required. So, this type of questions also can be asked in NEET, in board, in JEE. Okay. So, one thing only you have to remember, add the same quantity, subtract the same physical quantity. equate the same physical quantity. Clear? So I'll just move, you can take a pick, then we'll go to the next question of this type. Fine? Okay. So now let's go to another question of the same kind, in which if the velocity v of a particle is given to us as some expression which is seen there, what are the dimensions of A, B and C? Now if v is the velocity, then AT also should be velocity, and this term over also should have dimensions of velocity. So one by one we will see what to do. Okay, so now AT should have dimension of velocity. According to which principle again? Homogeneity principle. So A should have dimension of velocity divided by T. What is the dimension of velocity? M raised to 0, L raised to 1, T raised to minus 1, divided by dimension of time. T is T raised to 1. Okay, so my answer becomes M raised to 0, L raised to 1, T raised to minus 1. From here, this power goes up, so it becomes minus 1. So my answer for A becomes M raised to 0, L raised to 1, T raised to minus 2. So I have the dimension of A as M raised to 0, L raised to 1, T raised to minus 2. Same principle. Now let us go to B and C. Now before going to this full term, T is added to C. So if this is time, then C is also time, according to the principle of homogeneity. So what is my C first? There is no need of following the sequence. Whatever you get, you must do first. Correct? So C should have dimensions of time. So what are the dimensions of time? M raised to 0, L raised to 0, T raised to 1. We are ready. We are ready with C also. Now what is left out? B. So overall, we must have the dimension of velocity. There is no other route. So B upon T plus C must have the dimension of velocity. Every term must have the dimension of velocity. So overall, it must have dimension of velocity. So what is B? B is equal to dimension of velocity. I will just write M raised to 0, L raised to 1, T raised to minus 1. This is the dimension of velocity. Multiplied by dimension of time, because this has a dimension of time. Whether it is T or whether it is C, just now we wrote. So I must multiply the dimension of time. Correct? From here I have written. I have just taken this there so that I get B. Simple cross multiplication. Fine. So now I work out and get B is equal to M raised to 0, L raised to 1 plus 0, L raised to 1, and T raised to minus 1 plus 1. If I write T raised to minus 1 and this plus 1, it becomes 0. So what is my answer? M raised to 0, L raised to 1, T raised to 0. This is my dimensional analysis for B. So I got A, B, I got A, then C, then B. This is what is asked to me. Is it clear? So whenever added, same physical quantity. Whenever subtracted, same physical quantity. Whenever equated, here I equated it to the dimension of velocity. Why? Because every term must be a velocity. Understood? Okay. So you have to use your own pathway to get A, B and C. I hope I am clear. Okay. I'll just move and you take a screenshot of what is being done. Fine. Then we will go, after this we will follow the same principle of homogeneity, but in the next page I shall go to one new type of category of the same question. So we will see that. So keep watching till the end of the video. Fine. I'll just take a screenshot. Fine. Okay, now we will go to another page where I already explained what we will do. We have two numericals here in which there are exponent, I will make it yellow, power of E, or there is a bracket of sign, that is angle of sign, which is also called as argument, which is an angle theta itself. Now whether you have an exponent or whether you have an angle to be solved, they both are dimensionless quantities. What are they? Dimensionless quantities. So how do I denote them? Either by simply 1, 2, 3, 4 any constant, or by writing it as m raised to 0, l raised to 0, t raised to 0. This also means 1. Is it clear? Okay. So now I will read this question, then we shall do that, remembering that this is a dimensionless quantity. The position of a particle is given by the expression where t is the time and x is a distance. Find the dimension v naught and alpha. That is the question. Okay, find the dimension v naught and alpha. That is our question. Now, as I already said, we have to find our own track. So let me go to alpha t, which is dimensionless. Okay, so let me write alpha t is dimensionless. So how do I denote it? By 1. Or I can denote it by m raised to 0, l raised to 0, t raised to 0 also. Okay, so what is my alpha? Alpha is equal to 1 upon t. So what is my answer? M raised to 0, L raised to 0, T raised to minus 1. Because the dimensional formula of T is capital T raised to minus 1, because it is in the denominator, I took it to the numerator. So this is the dimension of alpha. Fine. Now I have to find out the dimension of V naught. Okay, if this is dimensionless, this is also dimensionless. Okay, both are dimensionless. So, V naught upon alpha should have the dimension of distance x. Why? We are using the principle of homogeneity. Equation should have same dimensions on both the sides. So, V naught upon alpha must have the dimension of x, which is the distance. Agreed? So now I want V naught. I will write dimension of distance. What is the dimension of distance? M raised to 0, L raised to 1, T raised to 0. Multiplied, remember I must write a square bracket always for dimension. You cannot write a normal bracket. Okay, multiplied by the dimension of alpha. I have to take it that side to get V naught. What is the dimension of alpha I got just now? M raised to 0, L raised to 0, T raised to minus 1. Fine. So what is the dimension of V naught? M raised to 0 plus 0, 0. L raised to 1 plus 0, 1. T raised to 0 minus 1, minus 1. So I am ready with the dimension of V naught. Fine. So what is the dimension of V naught? That you can see. Fine. So I'll just move. You can take a pick. Then we will go to that part of the board with another question. Fine. Okay. So now I shall go to this question in which I am asked what is the dimension formula of omega and k from this equation. Agreed? Now omega and k, they both are physical quantities. Okay? But they are within the bracket of sign. Anything within the bracket of sign is called an argument. It is an angle. Sine 30, sine 40, sine 50, sine 180, sine 90, whatever. But it is a dimensionless quantity. It's a number. Understood? So if it is dimensionless, then each term should be written as 1 or m raised to 0, l raised to 0, t raised to 0. This time, let us write it as omega t. Whole term I should write because each are dimensionless. Omega t is dimensionless. So I write it as m raised to 0, l raised to 0, t raised to 0. So I want omega. So I will write it as m raised to 0, l raised to 0, t raised to 0. I could have written it as 1 also, but I just wanted to show that here I have written 1. Here I have written this expression. Fine. Divided by the dimension of t. T I am bringing down. T raised to 1. So what is my answer? Okay. T raised to 1. This is what? This is the dimension of time. So what is my answer? M raised to 0, L raised to 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 1, minus 1. So my dimension of omega are ready. Same way, what is the dimension of kx? Dimensionless. So how should I represent it as? K I want. So dimensionless, so how I will write? M raised to 0, L raised to 0, T raised to 0 divided by dimension of x. What is dimension of x? M raised to 0, L raised to 1, T raised to 0 because x is distance. Clear? Okay. So what is my answer for k? M raised to 0 minus 0, 0. L raised to 0 minus 1, negative 1. And t raised to 0 minus 0, 0. So finally I have k is equal to m raised to 0, l raised to minus 1, t raised to 0. I am ready with the dimension of k also. Okay. So keep it in mind. Whenever there is exponential form, power is dimensionless. Okay, and whenever there is a sine function, its argument, its theta is dimensionless. Every term is dimensionless. If they are dimensionless, then what should I write? Either 1, I have written in this one, or m raised to 0, l raised to 0, t raised to 0, which I have mentioned here and here. Fine. Okay, so I will just move. You take a pic of the whole page and this specially and understand this category of question which we can solve with the same principle of homogeneity.